Okay, so in this particular case, we've got AgI, which is silver iodide, reacting with Na₂S, producing Ag₂S and NaI, right? So that sodium sulfide, this reaction is basically a precipitation reaction. I mean, the Ag₂S is it's not soluble, so I mean, this is overall it's like a precipitation reaction, but we're going to focus on just the balancing aspect of this rather than the reactivity, right? So, but in terms of balancing, this question asks us, well, please, it asks us to put numbers in front of the equation, work out what those numbers would be such that it would be balanced and no need to use whole numbers. So the first thing I'm going to do to work this out is I'm going to do a process of effectively auditing what I actually have in front of me. So what do I have in front of me on the left hand side? What do I have in front of me on the right hand side? And that is meant specifically in terms of the number of occurrence of each element, right? Whether it's atoms, ions, whatever, but the occurrence of the frequency of occurrence of each element, I'm going to effectively work on accounting for that. So in this case, the initial focus, let's do the left hand side first, right? So I'll just do LHS as an abbreviation for left hand side, and to RHS as the focus for the abbreviation for the right hand side. So we've got silver, iodide, we've got sodium, we've got sulfur. So it's AgI NaS, okay. AgI NaS, right? Okay, so within the context of this, let's work out for silver. We've got 1. It occurs once. It's only in this initial species AgI on the reactant side. So it's going to be 1. Iodine, or in this case, well, we've got iodide, but it's the occurrence of I anyway. So that's going to be a 1. Sodium. So here we've got Na2, right? So that's going to be 2, and sulfur we've just got 1, right? If we do the same for the right hand side, Ag2, so we're going to have a 2 there, right? It doesn't occur in the NaI, right? Of course. So for I, we've got that appears once, right? I threw an I by accident. That occurs once. I put a 1 there. Na, I'm going to put a 1. And for sulfur, that you can see Ag2S, so that just occurs once, right? So we've got 1 1 2 1 2 1 1. So what do we have? Effectively, the sodium is not balanced. The iodide is balanced. The sodium is wait, I didn't call that sodium, did I? Hopefully I didn't. But the silver, yeah. So the silver is not balanced. The iodide is balanced. Sodium is not balanced. And sulfur, I mean, it occurs once on both sides, so we could say it's quote unquote balanced. But anyway, let's go through the process of iteratively, or should I say systematically, working through this so that everything will be balanced. What I'm going to focus on first is, well, as you can see, silver occurs in 2 places, right? It occurs in the species AgI on the left hand side. It occurs in the species Ag₂S, right, on the right hand side. Now, if we wanted to get that balanced, really we would need to modify, in the first instance, the AgI, right? So we need to put some sort of coefficient in front of that to make it balanced with the right hand side. So I'm going to approach that by putting a 2 in front of the Ag. well, on the left hand side, and seeing what we get out of that, and then looking at the subsequent steps. So that will effectively give us so I'm going to use a different color for this. So if you put here 2, right, AgI, right, plus Na₂S, and then that produces AgI₂S plus NaI, right? So if we now audit the new equation that we have, what we should be aware of is that because we didn't actually modify anything on the right hand side, the output, when we do effectively tally out what we've got, it's going to be the same as what it previously was, right? So it's literally just going to be the same as this, right? So AgI NaS, right? So we're going to have 2, 1, 1, 1, 1, just like it was before. We did make a modification on the left hand side, so that's not going to be the same. So let's carefully work our way through what that's going to be now, right? So that's effectively going to be, this is going to be multiplied by 2 from what it was before. So 2 AgI, so we're going to have a 2 here. I as well is going to be multiplied by 2, as you can see. So that's going to be a 2 rather than the 1 that it was before. Sodium is still going to be as it is, Na2. And sulfur doesn't change, so that's just going to be 1 as it was before. Right. So if we look at the new values we've got here, we can see that sodium now is the same on both sides, and sulfur is the same on both sides. But as far as iodine and I may have just called sodium silver again. I mean silver. I may have just called silver sodium again. I don't know how I get those confused, but silver is the same on both sides, right? Ag is the same on both sides, and iodine obviously is not balanced. Sodium is got 2 on the left hand side and 1 on the right hand side, and as far as sulfur goes, we can see it is effectively, arguably balanced. But let's see what we get in the next iteration. Effectively, let's look at the sodium. So for sodium, we need to have 2 on the right hand side if we want it to be equal to what we've got on the left hand side, right? So what we could do is we could put 2 in front of the NaI, right, and see what we get. So and that would effectively get us the increase we need to have the same sodium. Though of course that has some consequences for iodine. However, that may possibly be actually a positive thing in this case, given that the iodine is also not balanced so far. Okay, so let's look at what that new equation is going to look like, right? So we're going to put 2 AgI as it was before, and then that produces Ag₂S. And so here is the new thing, right? So we're going to put a 2 in front of the AgI. Okay, so with this change, let's do another audit and see what actually is produced. Now, we didn't change anything on the left hand side, so the left hand side is going to be the same as it was before, right? So AgI Na₂S, right? So we're gonna have just what it was, right? but on the right hand side, we have made a change, right? So Ag₂S to AgI, right? So let me just write this out, AgI₂S. So if we look at the sodium here, okay, that shouldn't be an Ag, right? I think I've probably put the wrong. That should be NaI, right? So 2 NaI. Okay. So if we do our counting for the in this case the so Ag2, right? So we're going to have 2 here, and for sulfur it's the same. We didn't modify the Ag2 in this iteration, so that's just going to be 1 as it was before. We've done effectively, we've put the coefficient of 2 in front of the NaI, right? So we're going to have a 2 here and a 2 here, right? And so if we now compare both sides of the equation, what do we find? Well, we find that the sodium is balanced, or should I say, for whatever reason, I keep calling the gold, I mean not the gold, the silver, I keep calling the silver sodium, but I think because one kind of, they both begin with an S. Yeah, so the silver is balanced, the iodine is balanced, the sodium is balanced, and the sulfur is balanced, right? So, I mean, given that, we can fairly confidently say that actually this equation that we now have is our balanced equation, right? And so we've got a 2 in front of the AgI, a 2 in front of the NaI, right? So the equation up here, and the other thing, these are all whole numbers, right? So as the question did specify, please use only whole numbers, and that's exactly what we've done. Put 2 here and a 2 here, right? Okay, so this would be our, as I said, this would be our balanced equation. All right.